Okay. Good afternoon, everyone. In today's session, or in today's lecture, rather, we are going to start with the module number three, and that is mobile networking. Okay. So, in this particular module, we will we are required some basic concepts that we are going to revise from computer networks, like different layers of OSI model, then different protocols that are used in those layer, and what are the functions of those protocols. Okay, that we are going to see. Okay, in today's lecture, we'll start with the mobile networking. Basically, we'll start with the what is mobile networking. Okay, so it is simply just a networking in mobile communication or mobile communication system, you can say. So here networking means the primary concern is here with three layers. The one is the medium access layer, which is a part of data link layer, then the network layer, and the transport layer. Okay, so we are talking about these three layers. The media access layer, network layer, and transport layer. Okay, so these three layers are area of interest for our this particular module. Okay, now in this module we will see how networking in mobile communication is different than the networking in the wired communication, because we know the mobile communication is the wireless communication, and what we have studied in previous semesters is about the wired network. The computer networking concept that we have studied is about the wired network. Okay, so first of all, we'll see MAC layer. Okay, so primary job of MAC layer is deciding the way in which the users can access the medium of communication. Okay, so we have studied different methods of multiple access techniques, like we have seen time division multiplexing, we have seen frequency division multiplexing, we have seen code division multiplexing. Okay, so these are the different ways in which users can access the shared medium. Okay, so most of the time medium is shared, that we understood. Okay, so you have to decide how each user will access the given medium, whether it is based on time, whether it is based on frequency, or it is based on code division or code. Okay, so apart from this basic three multiple access techniques, we have also studied one another technique that is called as CSMA, that is carrier sense multiple access. Okay, so several techniques are present in the MAC layer. Okay, then comes the network layer. Okay, so network layer primarily concerned with the routing of the data or routing of information throughout the network. Okay, means how senders data will be delivered to the receiver via different routes that may be decided by the network layer. Okay, so apart from that, it also concern I'm talking about the network layer, it also concern with the addressing of each node within the network. Okay, to route the data, you need to uh, address. So each node in the network, how you are routing your data, means if you take an example, just like delivering a mail, you need to have an email id, then and then only you can receive emails. So similar to that, so each node must have an address within the network to which the data can be delivered or routed. Okay, so then comes a transport layer. Transport layer concerns about with or concerned with the making sure whether the data is delivered or not, or how to deliver a data to the particular node. Okay, then it also concerned with the problems encountered during the delivery of the information, like whether congestion happens or not, whether whether there is a mismatch in transmission and reception rate or what. Okay, so that is called flow control. So it is taking care of that. So So what if problem occurs in while transmitting data? So that thing will be taken care with the transport layer, or that is handled by the transport layer. Okay. So the next question arises, whatever protocols or which are implemented for the fixed network, because all these things we have seen in relation with the fixed network only. Okay. So whatever protocol which are implemented for fixed network or the wired network, we can say, can we apply these same protocol or the same methods in the mobile networks or mobile communication or not? That is the question. Okay. So let's see one by one. For the MAC layer, apart from deciding the way in which user can access the medium, the next task of MAC layer is, when it assigns the method to access a medium, the next task will be to avoid the collision, okay, or collisions. Okay. So when user are accessing the medium, so for suppose for example, if a MAC layer decides that FDMA should be implemented, then definitely different frequencies are allotted to each user. Now MAC layer has to ensure that when or modes are when different nodes are using the different frequencies, then their data will not interfere with each other. Okay. That means it should avoid the collision, and that's why we have a protocol named as CSMACD for fixed network. Okay. So we have studied that particular thing previously also. CSMA, that we know that it is a carrier sales multiple access, and CD is collision detection. Okay. Then the network layer, whose job is to route the information or route packets and address the each node within the network. That is the network layer purpose. So now while addressing the node within the network layer has to ensure each node must get a unique identification so that delivery of the packet will become easier. Okay. So apart from that, how to route the packet towards the destination, that is also a job of network layer. So protocols such as RIP protocol, then OSPF, that is open shortest path first. Okay. So these are the protocol which founds the best possible route to deliver the packet to the network. So these are for routing, whereas the IP is also a network layer protocol. Okay. So this is for addressing. So network layer has two different sets of protocol. One is for addressing, that is IP, and second is RIP and OSPF like protocol. This category is for routing purpose. Okay. So both are part of network layer only. So are these protocol implementable in the mobile communication also? That we need to check. Okay. So we will see that. Then comes a transport layer. We know that for transport layer, we use TCP and UDP. So their job is to decide or to ensure or not to ensure the delivery of the packets, depending on what kind of protocol we are using. So TCP ensures delivery of packets, and as UDP does not care whether the packet is delivered or not. So that is a functioning of it. So apart from that, they also try to sustain the connection throughout the communication. That means if connection is broken, TCP will take countermeasures to redeliver the lost packets. Such thing is not there, or such things do not happen in the case of UDP. But both the protocols have their application areas. Based on that, the protocols are working. So we are not going to discuss them right now, but the TCP and UDP are the main protocols which are the part of transport layer. Okay. So can we apply these protocols or these methods from fixed networks to the wireless networks or to the mobile communications? Okay. So that is the basic questions. So we will see the solution or answer to this particular question. So let's first discuss about the MAC layer. Okay. So the same question again asked, that can we apply the medium access methods of fixed network into the wireless networks? So for that, let's take an example, that is CSMA CD. We'll start with this. Okay. So carrier sends multiple access with collision detection. So what is the principle of CSMA? CSMA means a carrier sense, that is sensing a carrier, means what? That sense whether a medium is free or not. Okay, so whenever you find out a medium is free, that whenever you sense immediately, that is carrier sensing. So if a node finds that medium is free, it sends the packet it has immediately. Okay, so now after sending a packet, the node, that is a sender, continuously listen to the medium to check whether collision has occurred or not. Okay, so let's say we have one particular node. This is a node, it is sending, and this is the other node to which it is sending. Okay, suppose this node is sending a packet. Okay, and it will listen to the medium. This is the medium, path is the medium, to check whether the collision has occurred or not. So this concept of, or this particular principle is used in the Ethernet, that is IEEE 802.3, and can we apply the same method in the case of wireless network, that we need to check. So now let's see that what will be the problem if we implement the simple, this particular same technique as it is in the wireless network. Now what are the problems that we'll see? So the first of all, in wireless network, signal strength decreases in proportion to the square of distance. That principle we know. So when you move away from a sender, the signal strength of that particular sent packet will continuously start decreasing. Okay, so this does not happen in case of wired network, because in wired networks we have a dedicated medium and fixed medium to which the external factors do not impact directly. Okay, like atmospheric conditions do not impact. But in the case of wireless network, you don't have a physical medium, so signal strength continuously gets decreasing or gets decreases. Okay, so how will this particular impact is there in the wireless network? So that we'll see. So now the sender would apply, suppose, CS and CD, that means carrier sense and collision detection, but collision happens at the receiver. Okay, so in short, CSMA CD detects the collision when it occurs at the receiver. Okay, so what if the collision occurs at the transmitter itself? We will see this scenario later on this particular lecture. Okay, so it might be the case that collision occurs at the receiver and sender does not hear it. Okay, that can happen in the case of wireless network. Okay, so that will not happen in the case of wired one or wired network, because in wired network we know that we have a dedicated physical wire associated with it. In case of a wireless network, we don't have it. Okay, for example, after sending a packet, okay, the receiver did not receive it because of several reasons, and that comes an obstacle afterwards in between sender and receiver. So because of that, sender is not able to hear the collision at the receiver end. Okay, so here carrier sensing and collision detection concept of CSMACD is failed in this particular case. So sender is not able to hear the collision, and collision which is at the receiver end. So sometimes carrier sensing also not work. Okay, if the terminals are hidden, so that we'll see what it exactly means. So what is the hidden terminal, that we will see. But sometimes if there is a collision at the transmitter end, CSMA is not equipped for that particular thing. So CSMA only interested in collision at the receiver. So that is the problem in the case of wireless implementing CSMA CD in wireless network. Okay, so how does collision occurs at the transmitter end? We will see that. Okay, so that is called as a hidden terminal problem. So we'll see what is a hidden terminal problem. Okay, so what are the hidden terminals? So suppose let's consider a scenario where there are three mobile stations. Here you can see the A, B and C. There are three mobile stations because we are talking about the wireless networks. So we know that multiple devices are there. So now there is no physical medium present. So each station has its own transmission, or we can say the detection range. Okay. So we can see A, B, C, three terminals are there. So here you can see with the blue color, this is the range for terminal A. Okay. Now in a red color, this is a terminal, this is a range for terminal B. Okay. Then with the yellow color, this is the terminal, this is the range for a terminal C or node C. Okay. So now consider a case where A is sending to B. Consider a case where A wants to send a packet to B. Okay. And as you can see, C is not in the range of A, though it is interfered here somewhat, but it is not that much which can help you out. But you can see C is not in the range of A. Here see the C ka range agar aap dekhoge, so we will see that C is not in the range of A, whereas A is also not in the range of C. Only B is there who is in the range of A as well as with the range of in the range of C. Okay. Because A can transmit only up to the this distance. A का transmission यहाँ तक ही possible है. Okay. So C cannot receive what A has sent. Okay. Now if suppose C wants to send the data to B. If suppose C wants to send the data to B. पहले मैंने क्या बोला that A is sending data to B. A is sending data to B. Okay. Now C also wants to send the data to B. Okay. That means, sorry, C wants to send the data to B. Okay. So first thing it will do in the case of CSMA is that it will sense the medium. Okay. What is the medium of C? So this particular, the whole region, that is a medium of C. Now it will notice that this medium is free. Okay. So it will try to send the data to B, but B is already receiving packets from A. Okay. So at that time, B will receive packet from A as well as C is also which is trying to send a packet. So B will have the packets from A as well as from C. Okay. And collision will occur at node B. Okay. But this will not detected by A. Why? Because A cannot hear C. Because you can see the range of A is limited up to the here only. So what C is sending is not in a range of A. So A will not able to hear C. Okay. So A is failing to hear a collision at B because collision is happening because of C. So collision detection is failed here. Okay. In this case, and carrier sensing also failed because C is sensing the medium free, whereas actually B is receiving data from A also. Okay. So carrier sensing is also get failed. So that is collision at the transmission and the collision at detection fails. So it is a collision at receiver also fails. So now in such scenario, we can say that A is hidden from C. Why? Because C don't know that A is already transmitting something. A also don't know that C is trying to send to B because they both are not in a range of each. Okay. So A is unaware of C and C is unaware of A. But because of both wanting to send the data to B, which is a part of range of both the terminals. Okay, so collision occurs at B and data will get lost. Okay, so this is called a hidden terminal problem. Okay, so CSMA CD in wireless network faces one kind of problem. The first kind of problem, that is a hidden terminal problem. Now we'll see the next problem, or you will see the further issues related to this. Okay. Now next problem is that the CSMA CD encounters is the exposed terminal. Okay. Now consider the same scenario again. Now here again, B is sending to A, suppose थोड़ा उल्टा condition है, B is sending to A now. B is sending to A. Okay. Now C wants to send to some another terminal. Okay. Suppose यहाँ पे मैं एक terminal बनाता हूँ. इसको मैं D नाम देता हूँ. उसका रेंजिंग रहेगा सपोज ये, this will be the range for it. Okay. Now C wants to send to D. Okay. Now this should be perfectly capable or perfectly possible in the wired networks, because there will be the wired connection between A to B as well as the wired connection between C to D is already there, and no collision will occur because they both will sense each other, and they will see that both are free. A is also free, not having any communication going on, as well as B is free, not having any communication going on. So the information or delivery of the information will be possible, or very easily we can do it, and no collision will occur. Okay. But then here what's happening, let's see that. So B is sending to A here, and C wants to send to D here. Now before sending to D, what C will do, C will first sense the medium. Since C is the part of here, C, the part of medium of B as well as part of medium of C is interfered, and it will sense that. Okay, you have also seen that the circle here, you can see this yellow circle and red circle, just concentrate on that. Okay, which constitutes the terminal B, A, and this yellow circle is also constitute of circle, circle D also, D ka part also, some part of D also. Okay. So what will happen? So when C has to send the data to D, it will first sense the medium, and it will observe that medium is busy because of B, or because B is sending to A. So C waits here. So actually C does not need to wait. Okay, or doesn't need to wait, because C is not associated with the communication which is happening between B and A. But still C will wait. Why? Because medium is busy. Okay, and we know that, or we can see that A is not a part of C. A, because A ka range is ending at B. So C should not wait for B to stop or to complete its communication to A. It can immediately start its communication. So this unnecessary waiting is exposing C to B. Okay, so this is called as a exposed terminal problem. Okay, this is called as a exposed terminal problem, where one station is trying to transmit to another station, and the third station is trying to transmit to fourth station. Okay, but unnecessary waiting occurs because of the sharing of medium. Okay, so here carrier sensing is failed. Okay, and collision will never happen, but the carrier sensing is failed down here, and that's why channel is not utilized efficiently. Okay, so this problem is called as a exposed terminal problem. Okay, so carrier sense fails in the exposed terminal problem. So carrier sense, collision detection, both we have seen failed in the case of hidden terminal problem. Now let's see the another issue which can be encountered while implementing CSMA-CD in the wireless network or mobile net communication network. That problem is known as near and far terminal. That problem is known as near and far terminal. Okay, so we have already seen in the previous lectures. Let's see it again. Let's say there are two terminals like A and B. Here it is shown with their respective ranges shown in the diagram. Blue line is the range for A, whereas the red line is the range for B. Okay. Now, both A and B sends the data to C. So A is sending the data to C and B is sending data to C. Now we know that here signal strength in the case of wireless network decreases with square of the distance. So B signal will reach terminal C at a higher strength that we have seen. So compared to the A signal, which is reaching to terminal C. So B will have a much strongest signal or stronger signal as compared to the A. Okay, so that will be A will be much weaker signal, and because of this, C will always accept a signal from B. Okay, so this is called as a B is drowning out A. This is known as a drowning. So B is drowning out A. Okay, so since B is closer to C, its signal will not degrade so much as compared to the A signal, which is far from a terminal C, or which is far away from terminal C. So its signal will degrade, A signal will degrade much more compared to the signal which is sending B. So C will never receive a signal from A, and it will always receive a signal from B. So this kind of issue, because of the distance between two different senders with the destination, is called as near and far terminal, where B is the near terminal and A is a far terminal. So this issue is most of the time found out in the CSMA network, because in CSMA network every terminal is sending with the same power, and in that case the signal with the greater strength or staying greater power will always be accepted, and signal with a lesser power will always be rejected. Now in worst case, suppose if C is, let's say, server or master or administrator who is assigning certain rights to different terminals within its network, suppose C will, in that case C will never assign any kind of right to A. So A, although has a perfectly functional conditions, it will never be able to transmit anything, or it will never be able to communicate with anyone, because it will never get a permission from C. Okay, so this is called as near and far terminal, and because of this, three main issues in CSMA CD cannot be implemented as it is in the wireless network, because in wireless network carrier sensing gets fail. That means collision may happen at transmitter end also, and collision detection may get fail. So that means if the terminals are hidden, the terminals will be unaware of the collision at the receiver, or because of near and far issues. So certain terminal will never get a chance to communicate with the network also. Okay, so these are some issues. So what will be the solution for this? That means what we can do, or how we can improve the CSMA CD in order to support for wireless network. So what solution we can apply? Okay, that solution is the modification to the particular protocol. Okay, so let's look at those methods in brief. But before moving that, we'll see something. So our focus is on providing the solution to implementation of CSMACD in the wireless media. So what are the different medium access methods that are available? Okay, so some of them we have already studied previously. Okay, like SDMA, that is space division multiple access, where we segment the space into different geographical regions. Okay, that is, one large geographical region is divided into smaller regions. Okay, if you remember the diagram, we have seen this diagram in model number 1 itself, that in space division we are dividing using basically cell structure, but that way the space is getting divided, okay, into smaller regions. And we use different directed antennas, maybe the sectorized antennas or the directed antennas, for to cover the each region. Okay, so different users can access the medium separately using the same frequency channel also. Okay, so that is observed in the cell structure, okay, in GSM. We have already seen HDMA there, and is rarely implemented alone. It is always implemented in conjunction with either TDMA or FDMA, or sometimes both also. This also we have seen. Okay, then the next one is frequency division multiple access. Okay, that is FDMA, in which we already saw that entire bandwidth will be divided into smaller bandwidths, and each user may be given different bandwidth for communication. Okay, so that avoids the interference from the each other. But the drawback of FDMA is we have very limited frequency resources, that is frequency channel allotted to us. So all users cannot be satisfied with this particular scheme. So then to avoid this, there is another solution, that is TDMA, that is time division multiple access, where everyone can access the bandwidth but not at the same time. Okay, but at the different times. Okay, so it at the means it is provided with the different time slots, so entire bandwidth is available for only a small amount of time. So again, it has a drawback, that if anyone wants to access the medium for longer time, then what it should do, so that is not fulfilled with the available TDMA. So each of these methods has certain drawbacks, or advantages also, but drawbacks also they have. And these are very basic multiple access methods or medium access methods we have already seen. Then the one that we have not seen previously, let's see them right now. You might have studied about that particular thing in CN. Okay, we'll just brush up what it is. So you might have studied about the ALOA scheme. That is, ALOA means, which is, you know that, okay, which is primarily used for accessing the medium in certain scenarios or for fixed networks. So there are two forms of it. One is pure ALOA, that is known as, or it is also called as classical ALOA. Okay, and then there is a slotted ALOA. Okay, what ALOA does is that basically in pure ALOA, suppose if a user has a data to transmit immediately, it starts transmitting it, so it doesn't wait to see whether the medium is free or not, or it is occupied by the someone or anything else, it will not check. So whenever a user has a data, it randomly start transmitting. Okay, so that is completely contrasting to the carrier sense multiple access. Okay, so advantages of this is very simple in nature. There is no coordination is required, so that is no coordination provided rather than required. Okay, so that means there is no administrator that is who that will check who is transmitting, when when it will going to transmit. So chances of collision are more in the case of pure or classical ALOA. Okay, but still it is a very simple to implement and provides the good efficiency under the light load conditions. Okay, so that means if a number of users are very less, so this schemes works very well. So you don't have to invest so much in implementation of this particular scheme. So about 18% channel efficiencies are observed in the pure ALOA, which is very low actually. By channel efficiency, what do you mean, or what we mean is that, let's suppose the channel is available for 24 hours, only 4 to 5 hours the channel will utilized by the users. Okay, for remaining hours channel remains unutilized. Okay, and that's why it gets wasted. Okay, so how to increase this particular channel efficiency, or how to avoid this wastage of channel? For that, and to avoid the collision which are observed in the pure ALOA or classical ALOA, they modified it to slotted ALOA. Okay, where whenever user has a data to transmit, it cannot directly start transmitting. It has to wait for beginning of a certain time slot. So entire time period will be divided into time slots, and if you have a data to transmit, you can begin transmitting it only at the beginning of each time slot. Okay, so up to certain extent collisions can be avoided, but not entirely it can be avoided, and it also improves the channel efficiency up to 36%. Okay, means by using this slotted ALOA, you have already studied both the methods in the computer networks, but slotted ALOA provides the better efficiency as compared to the classical ALOA. 36% means almost out of 24 hours, if you consider 8 hours, 8 to 9 hours, not 8 hours exactly, uh, 6 to 7 hours, 7 hours to 8 hours, up to 8 hours, it will provide with the, or your channel is utilized properly. But for remaining hours, it will be not utilized properly. Okay, so these are the Aloha schemes. Okay,